6/11. And that's 6/11. That's 7/11.
Okay, so all of the trig functions that we solved so far, and last week and really the week before last, because we were testing part of last week, we were finding side lengths. We would have said that the cosine, since Christian pointed out we've got adjacent and hypotenuse on this triangle, the cosine of theta is equal to 6/11, and that's where we stopped. But now we want to be able to use that to actually find out how many degrees theta is. Okay, so we've got to write it like Christian started us off, and you need to know why he said cosine, because looking from theta, you have adjacent and hypotenuse, right? Adjacent and hypotenuse is cosine. So we would say the cosine of angle theta is equal to 6/11. Now, we actually need to find the angle this time. We need to find theta. And so you could look at that as several different ways. If I just try to keep my algebra brain going, because we're pretty good at algebra, I would say, well, that kind of looks like cosine times theta, because they're right next to each other, right? This is just a simple thought. So usually in algebra, if something's being multiplied, you would do that by division, right? Well, we can't divide by cosine, but what we can do is take the inverse, because inverse is kind of like opposite. So we would say that the inverse, and that's that little -1, we would take the inverse of that. Okay, so I've got my calculator pulled up so we can go through, because this is gonna turn into a calculator now. So here's the big takeaway right now. The only time you do the inverse, which is what we're doing today, is when you have the trig function right next to your angle. Okay, trig function right next to theta, or if they named it an x or whatever. So on your calculator, on your Chromebook, or your handheld if you have one, first thing I need to make sure is that my calculator's in degree mode, because it can toggle back and forth between degrees and radians. So up here on the very top row next to second, I'm gonna hit mode. And I know you can't see all that on there, but you've got it pulled up on yours. I'm gonna scroll down about 1/4 of the way. And mine has radians highlighted, so I'm changing it to degrees. Right there. Okay, so now mine's flashing on degrees. So I'm gonna get out of that now that I'm in degrees.
You gotta click enter or something.
I gotta do
Yeah.
what?
You gotta
Okay.
click enter to activate it.
Okey-dokey, thank you. Alright, so now just to type in the problem that we had.
Didn't do it. It didn't do it.
See, like if you open it up again,
Now you gotta go down to it, go over and then click enter and then go back.
So, is that a degree?
Yes, degrees.
There you go.
there it goes.
Okay. So now the problem that we had said cosine -1, and I know you can't see my keys, but look at yours. Right here where my arrow is cosine, but above that in blue, it says the inverse of cosine. So I'm gonna hit second cosine, and that brings up the inverse of cosine. And then what was our problem, 6/11?
Yes, ma'am.
So I'm gonna go ahead and enter as a fraction. Okay, finally got all mine entered, y'all are ahead of me, and I hit enter. So that angle would be almost 57 degrees. Did y'all get that? 56.9, blah, blah, blah. So if we go back and look at our picture, that angle would be almost 57 degrees. So we would say angle theta. Find my marker again. Angle theta is approximately 57 degrees. Alright, I'm gonna erase that. I'm gonna show you one thing to try to keep you from getting confused on the next page, and then we'll work a few more. So, when to do the inverse button and when not to, if we just were asked for the cosine of 30 degrees, you would just type that just like it reads, because there's no variable right next to cosine, okay? But if we were asked, if we were told the cosine of theta is equal to 1/2, this is when you would do the inverse. So if it's, the angle is right next to the trig function, you would use the regular button. Actually, cosine of 30, I would just look on my unit circle, okay? But if you've got the variable or the theta right next to the function, you use the inverse button, okay? Everybody think they can keep that straight? Alright, let's do another one. Alrighty.
Well, on that quiz that we have on like Friday,
Mhm,
we would have things like cosine 30,
mhm.
but they wouldn't be on the unit circle, and we'd type them in, and they
Cosine
wouldn't.
30
give us-
is 2 on the unit circle.
I mean, like, if it, say it weren't on the unit circle,
Oh,
like, we would
okay.
have one that wasn't on the unit circle, we'd type
Yeah.
it in, and it would give us a wrong answer. Or we're typing it in wrong, or,
You could have been in the wrong mode, degrees or
Oh.
radians.
that's probably why. 'Cause I was probably in radian, yeah.
Probably like 20 feet.
Bro, that's trying to scale.
Okay, so it says a monster truck drives off a ramp in order to jump onto a row of cars. The ramp has a height of 8 feet. See how we would actually, our truck would be coming from this way, right?
Mm-hmm.
So a ramp has a height of 8 feet and a horizontal length of 20 feet. What's angle theta?
It's tangent.
Okay, so that's the first thing you have to figure out is what function are you dealing with? And so from angle theta, we know opposite and adjacent, which is tangent. So the tangent is opposite over adjacent.
And that 2/5.
Now you could go ahead and reduce that now. So take a 4 out of both of them like Mr. Tyler said. Okay, and so now is this gonna be the regular tangent button or the inverse tangent button? Inverse, because my tangent's right next to the theta. So we're gonna do the inverse tangent of 2/5. And about what is our angle?
22 degrees.
21.8, 22 degrees. So not very difficult now that you know to make sure you're in degrees and you know when to use the inverse and when not, right?
So you do that times,
Say that again, sir.
oh.
Oh.
One to try.
Alright, I'm gonna draw you now, on the next page, I'm gonna draw you 3 triangles. And I'm gonna let you try them on your own, see how you do.
3?
3. You got it, sir.
So this stuff only works on the right triangle. Right.
So far. We're going to get to the place where they don't have to be right. One more. Okay, see if you can find the measure of angle theta in those 3 triangles. for the first one up there in the top left, that's got the 4 and the 9, tell me what trig function I would use. Okay, I know adjacent and hypotenuse. Now, let me say this. If you just have nothing better to do and you wanted to spend some more time on these, you could use the Pythagorean theorem and find the opposite and then use sine. But that would just be giving yourself more work to do. Save yourself some time and work by using what's given. But I mean, you could do that, or you could, if you really like tangent, you could find this side and then use these two in tangent. But again, that's just more work than is needed. So, what they gave us from angle theta is adjacent and hypotenuse. So we would say the cosine of angle theta is equal to 4 over 9. Now, will you do the inverse cosine or the regular cosine?
Inverse.
Inverse, so the inverse cosine of 4/9 gives us our angle theta is approximately what?
64 degrees.
64 degrees.
64 what?
Now, if, I mean, I'm okay on the rounding to the whole degree, that's what I started you off on, I rounded the first one to the whole degree, but just pay attention to what your choices are. If they rounded it to like 63.6 or whatever, you know, just pay attention to what the choices are. Okay, so up here on the 8 and the 10, what do we know from angle theta? What function? Tangent, because we've got opposite and adjacent. So the tangent of angle theta is equal to opposite over adjacent, which is the same as 5 over 4. So you would say inverse tangent of 5 over 4, and what'd you get?
51.
About 51 degrees, very good. Okay, how about the last one? What trig function do you have?
Sine.
Sine of theta is equal to opposite over hypotenuse. So the inverse sine of 5/12 is about what?
25 degrees.
25 degrees. What you think about that?
Pretty simple.
A lot more simple than I thought.
Yep,
Yeah.
it's not very difficult once you see it, no problemos.
We
So,
got a handy calculator to use.
yep. When you take ACT test, if you take your calculator, that's one thing you're gonna wanna make sure of is what mode you're in, the degree or radian mode. Okay, so the question that y'all kept asking, especially you, Christian, about the 90-degree angle tomorrow. Today, we're not gonna have a 90-degree angle. We're gonna learn how to use the law of sines, and there won't be a 90-degree angle. Yes, sir.
I don't know if we're all gonna be here.
Miss Rocket said nobody was getting out until 10.
Yeah.
Got it, got it.
The law of sines, is that gonna have to do with the trig functions?